Welcome to the Matlab workshop, third level, Simulink and Simscape. So, inshallah, we will start with some simple ideas related to Simulink. Then we will, inshallah, upgrade them. We will start by simple mathematical operations. بعدين we will go to solving differential equations أو خلينا نحكي solving using. Then we will go into Simscape to discuss a mechanical system, a simple mechanical system. We have 2 hours, so we will try to discuss the system in details. It will be a vibrating mass mechanical system. Okay. طيب الآن when we say Simulink, الاسم ممكن يكون يخوف ولكن هو simply a graphical programming language. It's a graphical programming technique. Okay, so you program using blocks, programming using blocks. For example, خليني أحكي blocks and arrows، أو بالعامية خليني أحكيهم wires. Okay, I will come back to you here. Okay, so what do I mean by blocks and arrows? Can you see my screen?
Yes, doctor, we can.
Okay, so if I tell you I need to do a simple mathematical operation, 3 plus 5. Okay, if you are in Matlab, you go to the command prompt and you type 3 plus 5, enter, you will get the answer. If you go to Simulink, you have to use blocks. So in Simulink, I will give you blocks, something like, for example, this is a block for simple mathematical operation, addition. This is a block for multiplication. This is a block for, let's say, sine or trig functions. This is a block for whatever. This is a block, this can be plus minus, this can be differentiation and division. So multiple blocks, and you need to write your answer in a certain. ما هذا؟ Okay, and you need to write your answer in a certain location, so it can be something like screen, for example. Okay, for example, this is a block for len وهكذا. So what you need to do is to make a block for number 3 and make a block for the constant 5. Okay, and use the lines or the wires to add them together then display your result on a certain screen. Okay, for example, this is addition or summation block. And this is constant 3 block. وهكذا. So now if I give you, for example, let's say هاي ناخذ مثال من هون. And you have to think in the same way. So if I give you like square root of 5 plus, okay, so you start by, for example, constant 5 and constant 7. I have two constants. First of all, I need to find the to the power 2. So you need to certain function that takes it to the power 2. It's like steps of the mathematical operation. Then you need to add them together using the addition block. So I am here now. Then you have to take this and take the square root block. Then you go and display it in the screen. واضح يا شباب؟ طيب, so let's try this in Simulink. I'll start sharing from Matlab now. So this is the Matlab. Simulink is a toolbox in Matlab. If you need to start this toolbox, you just press on, or you just type One minute, please. Okay, so once you type Simulink, you will go to this screen. You press on, for example, let's go for a blank model. Okay, can you see my Simulink screen now?
Yes, doctor.
Okay, very good. Right. So I will go back to Simulink. You can save this. You can save this, and let's see what is the extension for this file. So you can save this as SLX Simulink model. Okay, so you have two extension, whatever. And this is your Simulink screen. This is your space. Here you provide, or you need to see the blocks and add the blocks together, tie them with the lines, tie them with the arrows, and have the result. So this is your Simulink basic screen. Now let's have an idea about the block. If you press here on the library browser, you will see some blocks. These are the most commonly blocks used, and these are the all blocks included in your version of MATLAB. Okay. So let me maximize this and let me go by the blocks step by step. So this is the commonly used block. For example, some of them I know, some of them I don't know. So it's all the like this. Some of them I know, for example, constant, convert, delay. Okay, these are the blocks that are commonly used. Integrator, scope, saturation, sum, product, gain, وهكذا. طبعا these are some mathematical blocks for calculus, for example, integrator, second integrator, derivative وهكذا. Dashboard. These are some programming for app designer. Blocks. يعني there is multiple types of blocks here. For example, these are the mathematical operations. Most of the mathematical operations are included here. Okay, if you don't have a certain mathematical operation, you can do it in the mathematical function. Sinks and sources. These are the screens. I told you there is some screens that you need to provide. So this is the display. It can display your result in a certain for a certain let's say operation. This is the scope. It can make a graph for you or for your results. These are the sources. You start within. If you have differential equation with time, you can use clock, for example. If you have time, if you have constant, for example, like we said before in the whiteboard, you can use it, whatever. Now there is some additional mathematical operations as well. It can be more advanced. Here, for example, I know the data acquisition toolbox, for example. Here you have the fuzzy logic toolbox. We will discuss the fuzzy logic in the final level. وهكذا. Okay, so let me start by a very simple operation. 3 plus 5 equals to something. Okay, so I need to add blocks that represent the value of constant 3. So let's check the commonly used block and take this block here. Okay, let's take another block for the constant 5. Okay, now here we have, if you can see the constant value, let me put 5 here. Okay, and let me put constant value 3 here. Okay, so far I have two constant. One of them is 5 and one of them is 3. I need to make a addition or summation operation. So I can go back and look for something that can be useful in a summation operation. So this block seems useful. So I can put it here. So this is a summation. Now for this summation, you know that, okay, let's leave it as it is, then we will discuss this. Okay, so this block will add 3 and 5 together. Now I need to display the result. Let's go back to the commonly used blocks. And I need a display. Okay, there is no display here. Okay, so let me go to source, go to sinks and bring the display. طبعا as you work كل ما نشتغل مع بعض أو كل ما تشتغلوا وتسووا تمارين بتصيروا تتعلموا على البلوكس، يعني بتصيروا تعرفوا كل بلوك شو الفائدة منه. Okay. Now let me tie them together. So I will tie this block to the addition. I will tie this block here, and I will tie this arrow here. Okay. So I have now a mathematical operation. I need to run this mathematical operation. So run. I got the value of 8, which is the summation of the two blocks or two constants. Okay. طيب. إلى الآن, so far so good. Do you have any problems with the blocks? With this mathematical operation, very simple mathematical operation. Okay.
So far, so good. No questions.
طيب, very good. الآن أنا الصوت عندي واضح. طيب. What about if I need to add another block? Okay. Let me add something like another block. No need to go to the block directory. I need to add مثلا 1, another constant. So I can press here. I can copy and paste. So I can copy this block, Control C and Control V. So Control C for copy and Control V for. Let me add a value of 1, for example. So now I need to add the value of 1. However, there is no input for the summation block. So what can I do? I can double click on the summation block and add another sign. So I can add another sign like this. So I have another summation block. I can bring this here, for example, and add it to them. Then I can run. Okay, so if I need to subtract this one, instead of adding, I need to subtract. You have two options. The first one is to use this as -1, for example. Run. Okay. Type. Now, I am not satisfied with the location of these signs, plus, plus, plus. So I can change the sign location by changing the value of this here. So if I change it, or if I put it here, let's see what happens. It is changing the location to this point. So if I add another one here, so now it can be very, let's say, the shape or it can be much better in terms of look. Okay, so you add them together, something like this. I'm not satisfied with this, so now it's like this. Okay, it's much better in terms of representation. Okay, so let's try to add a minus sign here. And return this to 1 and run. So we will get the same answer. So this works for plus and minus. Okay. واضح أيها الشباب؟ So you can try a simple example by yourself. Any example for a simple, let's say addition or subtraction operation. Now I can add some annotation for these lines. So if you press here, for example, on this line here, let's say signal from source 1, for example, any annotation. You can add this as well here, another annotation. From S2, for example. You can add annotation here just to show you, and this is very important actually. Usually once things get more complicated, you need to know your flow diagram of work, or so you need to better organize your work from the start. So it's better to give some annotations, especially when you are at the beginning of the let's say using, if you are a beginner in using Simulink, it's better to give these annotation, so it will help you in let's say checking the system and going back and forth to see if you have any problem or if anything is wrong. So usually we make this. You can also add annotation for the blocks, for example. So you can say this is constant. So you can say this is S1, for example. You can say this is S2. And you can say this is S3, for example. These are only some annotation to help you remember where are the signals are coming from and وهكذا. طيب. Let's do some more complex mathematical operation. So we will get like more experience in using the Simulink, and then we will go for the differential equation. So let me solve something like square root of 3 square plus 5 square. So I can go now and make another system. I go to File, New. Okay. So now I need to add blocks. Okay. There is another way of adding a block. If you remember the block that you want, you can start typing. So I will do this block, constant. Okay. You will have the options here. So I have constant. Okay. So I will copy this. I will have another constant. So I will add 3 here. And I will add 5 here. So I did not go to the library. I know the blocks that I need to use. So I started typing. Okay. Now for the power, I need to go for the mathematical operation and see which one of these will make the square. So we are looking for something that makes square. So this is absolute, add. Okay, so I don't think we will find. However, we can use this. If you don't find your mathematical operation, you can use this, the math function, and I will show you how to do it. Okay, so this is square root. Okay, so let's use this mathematical function here. Let's double click and see what happens here. You can select any mathematical function. There is some built-in mathematical function here. So I will select square, okay, and press on enter. So now it's a square. Okay, I need another one for the second. Okay, then I need a square root. I can go directly to the square root block. This is the square root block. However, before the square root, I need to add them together. So I need to add the summation. I start typing. So this is the sum. Okay, very good. I'm not satisfied with this location for plus here, so I can change it. Okay, very good. So now it's complete. I need also another block for the display, so I can start typing display. This is my display block. Okay. Now I need to combine them together. This one goes here, and this one goes here. This one goes here, and this one goes here. Okay, now your system is connected. You can press on run. Okay, and this is your answer. So let's try to put something that is 3, 5. Let's make it 3 and 4, so we will get 5. And let's try to run it again. So this is your answer. Okay, you can add the annotation here. It's up to you. Fine. Do you have any questions so far?
No questions.
Okay. Is there any students who are practicing with me on the Simulink? And it's better if you open the Matlab from the store and practicing with me in the Simulink. It can be a good idea. Okay, so let me make something more complex. For example, once I take the square root, let me take this here a little bit. I will delete this. Let me take the log, for example. I can go to the here to the mathematical operation and, for example, select log. Maybe you won't find a log, so you can take the mathematical operation again and take the log, for example, for the answer. Now I need to connect them. Okay. Type. So let me show you another way of connecting the blocks. الآن, usually we connect the blocks by bringing this, pressing on this arrow and this arrow. Okay. Output from this block to the input of this block. Now, if you press Control, okay, press on Control and hold Control, press on this block and press on this block, they will be connected automatically. Okay, this will help you if there is, like, sometimes it gets more complicated and this is not directly, so you need, this is not directly opposite to the previous block, so you have to press here and press here. You can do it. However, you can press and hold Control, press on the first block and press on the second block. You will get the connection directly. Okay, so let me now. Okay, so now you have this mathematical operation or this system, you can add whatever annotation you like. Okay. Type. So let me now make another. This will be the final mathematical operation. So I will use one of the examples that I have. Log 10 to minus 8 plus 9. Okay, so it will be a large one, however, we can manage. Where's your screen? Type. So let me open another one. Blank model. I will have 3 signals, and all of them are constants. So I will have constant. Okay. And I will I have another 2 constants. I need to add them together. So this can be, for example, 8. This can be 9. And this can be 20. I need to add them together, so I use the summation. However, I need to take, for example, the absolute for this one first. So, sorry, absolute of, let me make this minus 8. So I need to take the absolute first. So I will go and take the absolute. Where is the absolute block? I will connect this here. Then for the 9, I will multiply 9 by a certain number. I'm sorry, we did not talk about multiplication. We will talk about the multiplication now. So, okay. So multiplication in Simulink can be done using this block. It's called gain. Okay, it's called gain. So if you need to multiply 9 by a certain number, you put the gain here, or you put the number here. So I need to multiply 9 by, for example, 8. So I put 8 here. So this means that 9 will be multiplied by 8. Okay, this is the multiplication block. It's called gain. And I need to add the 20 to the block so I can make summation, for example, or sum. This is the sum block. I will put it here. I will add another sign. I will distribute the signs on the sides. Okay, I will add one here, and one here. Okay. And I need to take the log for this value here, so I can add a mathematical operation and select the log. Okay. Now from the other side, I need to add another 2 values, 2 constants. I need to add square root of 6 square plus 8 square. So we will have another, where is my screen? Okay, so we will have another constant. So I type constant. I'll get the constant. Control C, Control V. I will put 6 and 8. Now I need to take the square root, so I can copy this. Sorry, I want to make both of them as square, so I can put them here. Press here and select square, and here you can also select square. Let me connect. Now I will have a square root. So this is the square root. And I need to have a summation block to add them first. So sum. Okay. I can adjust the location of the plus by doing so like this. I will Control X, Control V. So now I can connect this here, and I can connect this here, and I can connect this here. So I need another summations to add it to the len. I can put this here. I'll take another summation. Or instead of doing this, I can take this directly because it's already adjusted. I can copy this here, and I copy this block here. Then I can provide a display, and I can provide a display here. So this is a circuit or a system. Now you can press on run to get your value. Okay. واضح يا شباب؟
Yes, clear.
طيب. So now I will go back to the whiteboard to start discussing about the differential equation and the integration using Simulink. So if you don't have any problem, I will go back to the whiteboard now to start discussing how can we solve or use this way of thinking or programming. Let's say I will call it a graphical programming technique in solving differential equations. So I can talk about solving. Or actually we will solve initial value problem using Simulink. So I will start by doing this differential equation. Suppose you have dx square y over dx square plus okay, d square y, let's make it by dt, plus dy over dt equals to 0. And I have initial conditions. Y prime is 0 equals to minus 0.5, and y of 0 equals to 3. So these are initial conditions. Now, if you look correctly at this differential equation, okay, so this means that y, if we say, for example, that d square y over dt square equals to y double prime, and dy over dt equals to y prime. So if you need to do this using Simulink, let's go to this equation here and write it in this form. Y double prime equals to minus y prime. Correct? Y double prime equals to minus y prime. طيب. So I have this. Y prime double prime equals to minus y prime. So if you have a block to integrate a certain signal, okay, in Simulink it will show something over S here, and it is called integrator. So you have to integrate once to get, I'm still now, I don't know what is the input here. The input, I don't know. However, I know the output from this first integrator, it will be y prime. Correct? So the input here, for example, you can say that it is y double prime. The output will be y prime. So if you integrate another time, this is another integrator, you will get y. صحيح؟ إلى الآن في مشاكل؟ I'm just doing the block ولكن عم بفكر فيه بصوت عالي. So the first integrator will take y double prime. It will give you y prime, then it will give you y. However, in our case, y double prime equals to minus y. Okay, so where is y? Sorry, y double prime equals to minus y prime. However, here we have y prime here. So this is y prime. So if you multiply y prime by minus 1, it will be equal to y prime. So you can connect them together here. This one, you put the first initial condition, and this one you put the second initial condition. So this is how you do it in Simulink. هنطبقها إن شاء الله. So انفهمت الآن كيف سويت هاي السيركت أو كيف سويت هاي البلوك دايجرام؟ Now, the first step is to provide a scope. Scope will give you a graph of y versus t. Okay. طيب خلينا نجرب مثال آخر. Let's try another example here. نشوف كيف بدنا نحكي عنه أو كيف بدنا نفكر فيه. Then we will go to the Simulink to do it. Let's say that d square y over dt square plus 2 dy over dt plus 5y equals to 1. And you have y prime is 0 equal, يعني these are initial conditions بغض النظر. Y is 0 equals to 0. I can only go for this example if you have fully understood this one. خلاص? This is one is fully understood.
Yes, they say also.
Type. Very good. Now, we can write this we can write this differential equation as y double prime equals to minus 2 y prime أو بلاش minus 2 خلينا نحكي 1 minus 2 y prime minus 5y. Correct? Okay, so let's make how many integrators we need? We need 2 integrators. So this is the first integrator and this is the second integrator. And this is the scope. تمام. الآن I will connect them together and let me see what is the input here. It is y double prime. What is the input here? It is y prime. What is the input here? It is y. Correct? طيب. الآن to get y prime, don't forget that y prime is composed of 3 entries. One of them is constant, one of them is minus 2y prime, one of them is minus 5y. So we start by taking the value of y prime and multiply it by minus 2. So this will be minus 2y prime. Okay, then we will take the value of y and multiply it by كم? Minus 5. So this will be minus 5y. So what is missing still? Okay, we need the value of constant equals to 1. So we can define a constant here. It is equal to 1. Then I can add them all to a summation block. What would be the result here? 1 minus 2y prime minus 5y, correct? And this summation is equal to y double prime, so you can connect them to the input of the first integrator. Okay? So what you need to do is always write the differential equation in this form, so it will be very easy for you to understand what is the value of y prime. So y double prime is the input for the first integrator. So what you need to do is always take branches from your system and make multiplication, different operation in order to get the value of y double prime. This will be your input for your first integrator. And here you add the boundary conditions. Y prime is 0 equals to 0. And for the second integrator, you get y is 0 equals to 0. Or you enter the second boundary condition. واضح المثال الثاني؟ Clear أيها الشباب? Is it clear? Both of the examples? طيب, so let me go back and start sharing from Matlab. Where is the Matlab? Okay, I will make a new blank model now. And let me see what is the operators. I need to find the integrator operator. So this is the integrator operator. Commonly used blocks. Usually it's here. This is the integrator. So we start by adding 2 integrators. So this is 1 copy, paste. We have two integrators now. Okay, I will connect them together and I will write here. Okay, here I will write this is y prime. Now I am solving the first equation or the first differential equation. D square y over dt square plus dy over dt equals to 0. Okay, now I need a scope to display the result. So I need a scope. This is the scope. It will display the result, or it will make a graph for. I will connect these together. تمام. And we said that y double prime equals to minus y prime. So we need to take a branch from here. How can we take a branch from here? If you press here, it will select the line. If you need to take a branch, you press on Control and press on the line. Okay. So this is a branch. Okay. Now there is nothing to the branch. However, this is only to show you how to take the branch. طيب. So we will take a branch from here. This will be equal to y prime, and we need to multiply it by a gain of -1. So we press or we start typing gain. We get the gain block. However, I am not satisfied with the gain block, because if I need to take a branch from here, I have to take a branch like this, and I have to go back and connect this here. Correct? So it's not that the shape, or I don't like how it looks. So I can flip this. How can you flip this? You can press on Control and I. It will flip directly. Control I. Or you can press right click here and go to rotate and flip and press on flip block. It will flip. Tamam? So before I do this, let's keep it more tidy. I'll remove it. I'll add it another time. So this is my gain. I will flip it. Okay. Then I will take a branch from y prime here. Okay. And I will take a branch here. Okay. But this should be -1. So I add a gain of -1 instead of 1. Now I need to add the initial conditions, sorry. So we said y of 0 equals to, or y prime of 0 equals to -0.5. So here you put your initial condition. Y prime of 0 is -0.5. Okay. Now for the second integrator, y of 0 equals to 3 as far as I remember. Okay. So now the system is correct. We can run. Okay. So where is the result? Where is the result? The result is in the scope. So if you double click on the scope, this is your solution. This is y versus t. Okay. If you look correctly here, y of 0 equals to 3, and it starts decaying. Okay. Type. What about the value of y prime? How can we get the result of y prime? Or for example, if you are concerned about the graph of y prime versus t, can you do it? How can you do it? Any answer or any idea?
Doctor, can you repeat?
Now this scope makes a graph between y and t. So if you press here, this will be y and this will be t. And this is the solution of your differential equation. Correct? Now, if you need a graph between y prime and t, not y and t, y prime and t, can you do it?
Huda says we branch from Y prime.
Exactly. So you add another scope here, and this scope will be y prime. So you can take a branch from here and connect it to the scope. Now you can run. Then you can get the value of y prime versus t. Okay, type. So maybe I am not concerned about this. This is done automatically by default from 0 to 1, from 0 to 10. However, I'm not concerned about this period. I'm only concerned about from 0 to 3. So can I do it? Yes, you go back here and you press here. You can change the X or the T values for your scope. So you can make it up to 3. Then you press on run. So now the first scope will give you from 0 to 3. Can you see the graph? Can you see my graph?
Yes, Doctor.
Okay. And the other scope can give you the value from 0 up to 3. Okay, so you can change or control the scope boundaries or the scope maximum and minimum values. واضح? Suppose you need it up to 20, you change it to 20 and you press on run and you can see the solution from 0 to 20. Okay? طيب, so let's try the other differential equation, the second one. I will go to a new file, blank model. Okay. Now we said we have two integrators. So I will add one integrator. Once you have the skill, it will be very easy for you. So once you have the skill, you can start, for example, typing, and you can make it in a very small time. So I have one integrator and I have another integrator. Okay, so I have two integrators here. I have a scope. Now, don't forget that now y w prime equals to 1 minus 2y prime minus 5y. Okay. I will connect these together. I will write here y prime. So I will not, and this is y. Okay. Now I need a gain. This is one gain. Yalla. Okay, I will flip it. Then I will copy this one here. Okay, I need a constant. So I add a constant here. I can flip it as well. Okay. طيب. So the first gain will be taken from y prime, branch from y prime. Control. The second gain will take from y. Okay. y prime, the gain of y prime, خليني أشيك بس كم حطيناه. minus 2, so this is equal to minus 2. and the gain for y equals to -5, so this should be equal to -5. Now this constant should be 1. Now I need to add them together, summation. I can flip this as well. I can add another sign. I can connect this one here. I can connect this one here, and I can connect this one here. Then I can connect this one. Okay, now the first boundary condition, 0, y of 0 equal, y prime of 0 equals to 0, and y of 0 equals to 0, خلاص. This is our differential equation. Let me add another scope here, so we will have an idea about y prime. Okay. So y double prime equals to -2y prime minus 5y plus 1. I will run now. Let me check the solution of y. This is y. Okay. This is the solution for the differential equation. This is y versus time. Okay, if you are concerned about y prime, it is something like this. This is y prime versus time. Okay? I will close this now. Would you like to like get one example to practice by yourself if you are practicing now on Matlab?
They are saying
okay.
Okay, so I will give you this example. And I will give you like 5 minutes to do it. Okay, so let me type. For y double prime minus 4y prime plus y equals to 0. Y of 0 equals to 1. Y prime of 0 equals to minus 1.5. So can you solve this differential equation or initial value problem using Simulink? I will give you like 5 minutes. Then we will do it. And I will do it on the Simulink. Okay. I'll switch off my microphone for 5 minutes, okay? السلام عليكم. طيب, did you solve it? Can you hear me?
Yes, doctor.
Yes,
But
very
can
good.
you tell them to feel free to raise their hand so we can unmute them and interact with you in a
Yes,
better way?
yes. Hi Fahad, send a picture, I will see it. Yes, very good. يعني minus k is the value. Okay. طيب, أتمنى إني ما أسكر هون. لا, I don't want to leave. Close, okay. Okay, very good. أي أحد عنده مشكلة بالحل for this differential equation? Any problem? خلاص? Yes, Salim. Can you send it? Picture or anything يعني. Salim, have you sent it already? لا. سالم 4 minus 4. Okay, Salim, if you need to do like this, بدك هون بس تخلص تجمعهم قبل ما تدخل على الانتجريتور الأول you have to multiply by 0.25 صح؟ يعني زي كأني بقسم على 4. زميلك فهد شو سوى؟ قسم كل واحدة هدول على 4، فهاي صارت 4، هاي صارت 1، وهاي صارت 1، وهاي صارت ربع. انت شو لازم تسوي؟ قبل ما تدخل على الانتجريتور هذا بدك تضرب في ربع. اوكي، فبتطلع عندك هاي المخرج من السميشن حيطلع عندك ماينس، حيطلع عندك 4y دبل برايم، فبدك تقسمه على 4 او تضربه في ربع. فهون بدك تركب جين 0.25 وتدخله على الانتجريتور عشان يصير مساوي لقيمة y دبل برايم. اوكي يا سالم؟ طيب very good. Okay, and I can see that you are following up. Okay, very good. So let's now take I prepared one example for you using Simscape. Actually, Simscape is a very large topic. We will make a mechanical system. So we will make a simple mechanical system using Simscape. Now, depending on your let's say, depending on your studies, depending on your topics, you can do any other system. يعني they are not that different. However, there is some like في خصوصية معينة للميكانيكال systems. Okay. So as we said, we will make. What can you see now? My whiteboard.
Yes, the whiteboard.
Okay, very good. Type. So we will make this system. I already have this system, and I will show it to you. Okay, so we have this mechanical system. It's a spring mass system. We have properties for the mass, half kg. Okay. So mass is half kg. We have properties for the damper or for the spring. It is 21 Newton per meter stiffness, and it is 0.5 Newton second per meter damping coefficient. Okay. Now what we need to do, this is the equilibrium position. In order to actuate this spring, we need to pull it to the right for 10 centimeters and leave it. Okay. So what happens now when you pull this mass or stretch the spring for 10 centimeter, it will start vibrating, correct? It will start vibrating for a certain time. Then it will go back to rest. So it starts from rest and it goes back to rest, correct? It will vibrate for a certain time, then it will go back to rest, correct? So we need to simulate this, and we need also to find the amplitude. We need to find the, for example, position of mass with the starting. يعني we need to find position versus time, and we need to graph, for example, velocity versus time. بحكي لي هون what is the time needed for the mass to come back to rest after actuation. Okay, so this is a simple mechanical system, and usually you start from the simple system and you can build any more complex system. So let's see how can we define this. I will go back and start sharing from Matlab. Where's the Matlab? Okay. Can you see my Matlab screen now?
Yes.
Okay, very good. So I will go to File, New, Model. Okay. And I will go to Simscape. Okay. Then I will go to multi-body system. I'm not sure still. Okay. So it opened a new system, a new blank, not blank model. This is called the Simscape Mechanical Multi-Body System. I will zoom a little bit here. Okay. Okay. Now for any, once you open it, by default, it will contain these 1, 2, 3 blocks, 4, 5, 6, 7, 8 blocks. This is a scope. Okay. Now this block is PS Simulink converter. From physical, okay, to Simulink. From physical to Simulink. So we need to provide the physical properties in this area here. This can be used sometimes, or sometimes can be, in our case, it will not be used. Okay, this block for the mass. Now we still need to add some other blocks for the, let's say, spring and whatever. Let's see what this block contains. If you double click here, this is the solver configuration. Now we don't need to play with anything with the solver unless there is some, let's say, another required tolerances that you need to add, for example, or you need to play with the solver. You can leave it as it is by default. Okay, we will not play with the solver properties. Okay, طبعا you should know that it uses the ODE 45 built-in function to solve the differential equation in mechanical systems. Now, this is the world frame. So you don't need to play with anything here. Actually, there is nothing to play with. Okay, and this is the mechanism configuration. You can, for example, change the value of G here. Now it is constant. You can make it variable, whatever. Okay, so we don't need to play with anything here as well. Okay, طيب for this block, خلينا بعد هذا شوي. For this block here, this is the properties of the mass. Now we have a mass of 0.5 kg and it has a certain dimension. We are not concerned about the dimension. Okay, so if you double click here, this will give you the mass or the shape and the mass properties. You can select any shape you like. If there is no certain shape, you can select cylinder. You can select any other shape. However, if you select cylinder, you can see that it is not changing to a cylinder or a sphere. You just need to ايش؟ هون بحكي لك message. Press F5. So if you press F5, يمكن أنا جهازي maybe I have to press function F5. Okay. يعني جهازي شوي غريب. ال F5 بدها function. I have to press function F5. It depends on your computer يعني. ولكن you have to hit the F5 button. And cylinder, I have to press on F5. It will update by automatically. I will keep it as a brick. F5. I will give it dimensions in centimeters. So I can select the dimensions to be centimeters and I can give it any dimension. So let's make it 20 centimeters by 20 centimeters by 5 centimeters. F5. Control مع function مع F5 sorry. Okay. Let's make it 10 centimeters بيطلع شكله أحلى. هاي F5. Okay. الآن inertia is the mass. You can enter the mass or density here. If you enter the density, it will take the geometry, it will take the volume and calculate the mass. Or you can make, you don't need to get to give any attention for the density. You just provide the mass and we can make it 5 kg. Okay, so let's press on F5, see what happens here. Nothing. Okay. Graphics, it can give you some other what is the shape or how can it make the shape, whatever. So we don't need to play anything. We just enter the mass and that's the most important here. We don't need to play with anything. So we can press on OK. تمام. الآن this one is the rigid transformation. What do you mean by rigid transformation? it can rotate the mass for you. So let me press here. For example, it can make rotation or translation for the mass. ولكن في شرط. This rigid transformation works with respect to the word frame. So it can change the rotation of the mass with respect to the word frame. So we don't need to play with the word frame at all. We just, if you need to make any rotation or translation, you can do it here. So I will make a rotation for this mass. وين الصفحة؟ معلش أنا صار عندي صفحات كتير دخلوا ببعض. خليني شوي بس أسكر الصفحات اللي مش مستخدمة عندي بالماتلاب عشان أعرف أشتغل. أعطوني دقيقة بس. نسكر هاي. نو. نسكر هاي. don't save. نسكر هاي. don't save. نسكر هاي. نسكر هاي كمان. اوكي. شو في هون؟ اوكي. So خليني اجيب ال rigid transformation here and let me make a rotation method based on a standard axis of plus y direction. We can rotate our element by 90 degrees, whatever you like. So I can press on OK. Tamam. Now we need to add the spring. Okay. The spring can be added from here. Yes.
You are not sharing.
I'm not sharing my screen. I'm very sorry. Maybe. Okay. Share content. Where is Matlab? لا. طيب مرة تانية معلش. مرة تانية. Hi, stop sharing. Share content. اوكي. ما سويت شيء انا على فكرة. بس مسكت هذا كان هون حطيته هون الآن. Now I changed the location of the rigid transformation only. Okay. And I made a rotation of 90 degrees. Okay. About the plus y axis. Okay. Now this is the mass. I don't need to play with the mass. I will add is. Now I will add the spring. The spring is located here. We go to the خليني أشوف وين موجود spring. Simscape. Press on Simscape. Foundation library. Let me see what's here. This is the found. Okay. Multi-body. Mechanical. Now which one? خليني أتذكر. Mechanism. I can't remember يعني exactly where is the location. بس بندور عليه تبع spring. ممكن نشوف مالتي بادي. Joints. Yes, this is the spring. We can represent the spring by a prismatic joint. So we can add this one here. Okay. Let me connect. Okay. I connected these together. Okay, this is the mass. خليها زي ما هي أو بلاش خليها هاي برا شوي. Let's add the spring first, then we will add the mass. طيب, so I will add this like this, and let me double click on the prismatic joint to see how or what can we change here. أول إشي state targets. Let me leave this a little bit and come back. Okay, let's go for the internal mechanics. Now the equilibrium position is 0 centimeter. Leave it as it is. Now here you can enter the spring stiffness. It is 21 Newton per meter, and you can add the damping coefficient 0.5. Okay, type. So actuation. We will not actuate the spring by a force. We will actuate the spring by stretching the equilibrium position into 10 centimeters. So how can we add this here? We go back to the first one, اللي هو state target, and we provide a value of 10. So specify position target. We need to يعني position target, we need to stretch the spring to 10 centimeters. Okay, this is our position target. Okay, we can select the value here, unit, make it 10, and press on 10 centimeters. Okay, actuation. Now we need to see the sensing. What you need to, or what are the outputs that you need to sense from this prismatic joint? I need to get the output of the position, velocity, and acceleration as well. Okay, so I can hit apply here, and I can hit OK. تمام. الآن الفورس it will be taken from the mass. يعني output of the force, okay, acting on the spring, it will be from the mass. If the mass is 0, the spring will not work. Now you have 3 signals here. One of them is P, V, and A. However, these are 3 of them, position, velocity, and acceleration. They are physical signals. Now we need to convert them to Simulink signals. So this is PS Simulink converter. Convert the input signal to unitless Simulink output signal. Okay, and this is a scope. By default, they are here, so I can take them. How many PS converter I need? I need 3. Depends on the how many signals I need. So I will copy of them, and I will have also 3 scopes. تمام. I have 3 scopes here. I will connect this here. I will take the first signal here. I will take the velocity signal here, and I will take the acceleration signal here. Okay. Now it should work. Now, if we press on enter, it should work. However, before it works, I need to show you how to add annotation for the lines, connections, and the blocks itself. Let me go to the rigid transform block and press on right click and go to properties. We can go to something called annotation block. Okay. Now we need to represent for the viewer or the user that we are rotating the block 90 degrees about the y-axis. So we can, these are the block properties token. So we can go to, for example, rotation angle. We can take it here and rotation angle unit. Okay, and we can hit apply. Okay, so now it mentions that it is 90 degrees. However, if you need to put the exact, for example, rotation angle equals to something, you can go back to block annotation, and here you can write rotation angle equals to rotation angle value whole unit. So now it shows that rotation angle is equals to 90 degrees. Okay. Let's do this for the mass, for example. We press on the mass, right click. We go to the block annotation. I need to provide the value of the mass. Okay. So I can go a little bit down and see. I will take this مرتين, and I will take the mass unit only once. شوف شو بدي أسوي فيهم الآن. apply. شو كتب لي؟ mass equals to 0.5 kgs. طيب, let's do this for the spring. أول إشي I need the stiffness. So spring stiffness here is we try to find the spring stiffness. I will add it once. I will add it twice. Okay, and I will add it again once here. X, I can add it here. Okay, and I also can add the damping coefficient. So where is the damping coefficient? 1, 2 والunits. Why did I add 2? So I can make this as the variable name stiffness. بجيب هاي جنبها على طول. damping coefficient يساوي, بجيب هاي وبجيب هاي. and في بس ضايل شغلة هون توقع هاي وهاي. apply. اوكي, فاعطاني كتب لي spring stiffness, كتب لي annotation equals to 21 نيوتن per meter. كان damping coefficient equals to 0.5 نيوتن per meter. طيب, الآن الأمور خلاص. we can press on. okay, we can press on run. okay, شو عم بيصير؟ now it's sliding, it start vibrating and it came to rest. واضح؟ ممكن ما تكون شايفين الماس. this is your mass. let's make it in 3D. okay, okay, can you see the mass now?
Yes, doctor.
Yes, doctor.
okay, so if you press on play here, you can see that it was stretched 10 centimeters. It started vibrating, then it came to rest. okay, so this is about the mass. Let's go back and check the scopes. so these are the scopes. Now we need to find the position versus time. If you double click on the scope here, you will get this is the position starting from 10 centimeters. It started vibrating. The amplitude was large or high at the beginning. Then it starts damping until it reaches until it goes back to the rest after maybe 8 or 9 seconds. Okay, What about the velocity? This is the scope of the velocity. It started from rest, 0. Then it starts for a certain velocity. طبعا you have to always remember that the velocity is the derivative of the position until it went back to the rest after 8 minutes. What about the acceleration? Again, it started from -4 meter per second square, and you have acceleration, amplitude for the acceleration, then it was damped after almost 8 seconds. All graphs shows you that it was damped after 8 or 9 seconds. Now, if you are not satisfied with these graphs, you need to add more points. You can press or change this value to 20 and run. And you can see your graphs now. Okay, it's clear that after maybe 10 seconds or 8 seconds, 9 seconds, it was damped. You can even make it 100 and let's make it 50. And see our scopes. You can say that, or you can see the scale is changing. واضح؟ أيها الشباب. Let me show you. Look at the, I will make it 10 again and run. Okay, so let me show you now if the spring was not stretched 10 centimeter, if it was compressed for 10 centimeters, what will happen here? Now remember, it started from 10 centimeter position. Okay, this is 0.1, it means 10 centimeters. So what happened if we compress the spring 10 centimeters instead of stretching the spring? We just changed it to -10 and apply. Okay, let's run and see what happens here. So now it started from a position of -0.1. Okay, now the equilibrium position that we have specified is 0. If you change the equilibrium position to a certain value, it will be also reflected here. Okay, whatever you change will be reflected here as well. So if you compress the spring, it will start from here. If you stretch the spring, it will start from above. وهكذا. Okay, just to recap, the vibrating mass, which is the most simple case, دائما وابدا once you open this multi-body, هدول دائما حيكونوا موجودات معك. These are properties for the solver and frame and G. This is the G or mechanism configuration. Okay, solver works on ODE 45 اللي درسناه المرة الماضية. This is the rigid transformation. You can specify any rotation or translation before you add the spring. This is for the body itself. Now we added the spring, we added stiffness, and we added damping coefficient. We also added the initial position, and we also added the stretching length or the stretched length. Mass, and we also added here 3 sensors, one for position, one for velocity, and one for acceleration. This is the mass connected to the prismatic joint or connected to the spring. Now the output here is sensed by 3 sensor. This is the position sensor. Before it goes to the scope, you have to convert it from physical signal to Simulink signal. And the same applies to the velocity signal and the acceleration signal. Okay, if you press run and you specify the number of points or the time needed for simulation, okay, you can double click on any one of these and get your solution. This is the solution for position, this is the solution for velocity, and this is the solution of acceleration. The last question was, what is the time needed for the mass to go back to rest? You check the solution. Once it goes to zero, this is zero. This is the zero line. Okay. Once it is damped and goes to zero, you can say that this is your time. 8 seconds, 9 seconds, whatever. Okay. If you are not satisfied with the time, you can add more time. And you can run. And you can see that it is for 100% after 10 seconds, it will be damped and goes back to rest. If you need to see this, the physical transformation or vibration, you can switch to this window block. You will have this window and you press on play. Okay, and you can see that after the timer is here. You can see that after maybe almost 8 seconds, it's still vibrating actually. Yes, here after 10 seconds, it went back to rest. You can also change the speed of vibration. Especially if you have high time values, you can change the view top. This is the top view, for example, and we can see anything here. So this is the front view. Okay, very good. طيب. Actually, I can't see your. Okay. Okay, can you make the graph look smoother? Yes, the graph, it depends on the time, and it depends also on the time. Yahuda, it depends on the time, and it depends also on the time steps. If you remember the ODE 45, we have the time steps. Here it's done automatically, but I'm sure there is something here that can change the time step. So it should be something here. It should be something here that can change the time step. However, math data, yani it is something here that can change the time step. But as we said, what we can do is to make the graphs to change the scale, and by changing the scale, yani there is some. Let me check here. Sample time. Okay, time span. Auto. User defined. Time display offset. Okay, where can we define it? Specify a valid time range. Where is the time range? 0.05 0.5. خلينا نجرب. Let's add another 0 here. Another 0 here. So it seems it's not. Okay, so time span, auto or user defined. يعني it should be something like I don't know exactly how it is entered. And exactly, I don't know how can you change the time span so it will make it. However, it should work. Okay. To show the characteristics of the graph, for example, yes, and overshoot. Yes, you can add them. I just added the time in seconds here. You can go and add some مثلا legend. You can add and these are properties of the scope. So you can add scaling, you can change the scaling. These are properties for the scope. You can play with them to get whatever you need. Okay. So this is plot as magnitude time and phase with time. Yani these are all our properties for the graph. Y label, it can be position, for example. Position in centimeters, or in meters actually. Apply. Okay. Okay. So let me check something here. Maybe this one is changing the time step. So I can press on apply here. Let's check what's happened here. Okay. I'm sure, Yahuda, that there is some variable here where you can change the time step. And once you change the time step, it will make it more smooth. Okay. I can't find it now, but I'm sure that there is something related to this. Okay. نرجع نشوف how show the characteristic of the graph, for example TRTS and overshoot. يعني characteristics are properties of the scope itself. On Abdulrahman, don't forget, can we make the graph look smoother? Okay. طيب. So that's all for level, I think this is level 3, Simulink and Simscape. We did a few simple examples and few simple programs and circuits on Simulink and Simscape. Now next week, I think, next week إيش حكينا عبد الرحمن حيكون عندنا؟